speaker for this session is Professor Prasenjit Mitra, who will be speaking on scholarly knowledge graph. And to give a very brief introduction of Professor Mitra, is an Associate Dean for Research and Professor in the College of Information Science and Technology in Penn. Over to you.
Thank you very much. So I will be talking about some applications of knowledge graphs that we have done in the CiteCRX project and in the general CR Suite project, which is sort of a generalization of CiteCRX that we did after we were working in several other different domains. So what is a knowledge graph? And I'm sort of explaining by an example. So a knowledge graph is essentially, you can think of it as nodes representing entities with edges representing relationships, and these relationships you can have as much or as little semantics as possible. For example, in the ORCAM is a namespace where we have these sorts of different terms that are defined. Now then we assign meaning to that. So this is sort of what my working definition of a knowledge graph is. And in CiteCR and CR Suite X and so on, so what we are doing it is to represent some real-world entities, in this case, for example, like a chemical or an atom or molecule, and also some amount of the knowledge of the document. So the document has a title and has an abstract and a citation and so on. The author is an entity who has a name and affiliation. The venue is another important entity for scholarly publications, and so on and so forth. So this is what the knowledge graphs underneath CiteCRX capture. And I will show you towards the end one application where we are using it to do better query answering. So our knowledge graphs, like a lot of other, like the previous project talked about triples and so on. So our knowledge graphs, like a lot of other knowledge graphs, are represented using RDF, which is just a simple triple format. It stores subject, object, predicate. And so this is showing some of the relationships between an author who has a home page and a paper which has a figure in it. It references another paper and so on. So this is what we are storing. And we use the OAI compliant metadata standards wherever available, and in some cases we expand them using our own sort of namespace. Okay. So the objective is to use existing standards. Several speakers in this digital library conference talked about Dublin Core. So using Dublin Core metadata, FOF is friend of a friend ontology that we use, which is has person metadata in it, and chemaxium metrology ontology, which was used for the chemistry metadata. And like I said, we have had to add and extend these metadata terms, so we define them and have a namespace where you can go and find these definitions. We were querying, this is sort of an example of the XML syntax of that RDM format, and then we use these to run sort of semantic queries. Okay, so each of these knowledge graphs has a data model, and I'll not, in the interest of time, I'll not go into those in as much detail, but I'll sort of go into some of the applications that we have done. So one of the applications that we have done is to build what is known as Collabseer, which is a collaborator recommendation search engine. And you can search for an author and essentially try to find collaborators based on some author and a set of topics. So if you're interested in yourself as being part of the team, you can put in your name, and then you can put in your area of interest. If I'm interested in image processing, I put in image processing, and it'll suggest potential authors who potentially have done work in similar areas that I'm interested in and have a chance for collaborating with. So this is sort of what it looked like, and it was sort of recommending the collaborators based on, in this case, generally just the name. So it picked up all the areas that person had worked with and gives you a set of people in ranked order. Okay, so this is again more of that. And one of the things that we use underneath is to figure out, like, if you're given two collaborators and you want to find the relationship between them, it goes in and looks at the knowledge graph, and this is sort of what you get in LinkedIn and so on, and it'll find collaborators who have common collaborators with you. Another application where we have used sort of the knowledge graph is in, we looked at author or collaborator suggestion and recommendation. So this one is recommending papers. So in this case, you can put in just a title, or you can put in an abstract, or you can put in some context. And in some cases, people have actually come in and put in their entire paper as a text string, and you can give just keywords to an entire paper, and our system would find recommendations for you. And underneath the covers, what this was, we have had various versions. So I think in the topic of citation recommendation and recommendation systems for scholarly articles, there are possibly over 200, possibly 250 papers. So we have, about 10 of them are ours from our group, and we have played around with different sorts of topic modeling using this method, latent digital allocation, by which we try to find recommendations. And until lately, along with the current trend, we use the we have modeled the recommendation problem using a deep learning setting, and it goes in and finds out the recommendations. But underneath the covers, this is using a graph of papers, authors, venues, and the year. These are sort of the fields from the bigger graph that it uses to find the recommendation. Now, in line with PageRank, which was as many of you perhaps know, was one of the major algorithms that we could say revolutionized search. Essentially, before PageRank, the idea was that you go in and you do something like TF-IDF, which means you look at the number of times the term appears in a document, and so on, and you figure out that, okay, this is the relevant document. And of course, to beat that system, scammers tried putting in perhaps invisible font 200 times. They would put in some of the popular terms, search terms, oftentimes names of celebrities. So it would be, Justin Bieber and Jennifer Aniston and whatever else would be put in invisible font underneath the page, even though the page had nothing to do with that. It was possibly a marketing page or a spam page. And just because of the terms, number of times you repeat it, those pages would come up, and the quality of search was not good. So PageRank, the fundamental innovation, which perhaps is not original to PageRank, because Kleinberg and his group had done some work called HITS and the Hubs and Authorities paper, and HITS, which relied on hubs and authorities. And essentially the idea there is that instead of considering the content on the page, or over and above that, we should consider what people linking to the page are saying about that page. And that's one of the fundamental sources of the signal in whatever version of RefSeer we are using, whether it is the LDA-based model or the deep learning-based model. What we are doing is we are using the context sentences. So if a paper has been referenced by another paper, what is the referring paper saying about this paper? And what is this about? And so on. So those are the sentences where a paper is referenced is called a context sentence, and we are capturing the context sentence and using that essentially as the major signal to figure out which of these should be ranked higher. Okay. This was expert search, so you want to find out, for example, in this case, expert in an area, and this would do essentially an author ranking and so on. Excuse me. So the essential idea here in using knowledge graphs, in this case I use sort of knowledge graphs loosely. The structure, the hierarchical structure under Wikipedia is a knowledge graph, and that has been used, and Wikipedia itself has been used to improve search engines. In fact, there was a talk by Google, I forget who it was, but they were saying that if there was another Wikipedia article, if there was another Wikipedia, then the quality of the search results would improve like an order of magnitude, and so on. So the essential idea is how do we leverage the relationships. And so I gave you sort of top level some applications. In the rest of the time, I want to show you how we are using these relationships a little bit more to find our answers. So in this case, I used the general search and a little bit of the recommendation search engine that we have. So the idea here is that you want to do a literature search and you have a query. Typically, if you have a literature search and you have a query, you can do whatever text similarity means that you have using TF-IDF, or you can use word embeddings, whatever your methods are. And that will give you, okay, these documents are the top ranked. However, what we have found is that just based on the text, you don't capture a lot of the knowledge that is there in a citation database. So, for example, however we might want to think, all authors are not the same. So there are some higher quality authors and some maybe not so high quality authors. And should we bias the higher quality authors more? There are some venues which are of higher quality than some of the others that are not reviewed as well. That knowledge is there in the CiteSphere knowledge base. Should we use that? Now, one of the approaches that we used in ranking, like the PageRank, is to do a random walk. So essentially, the random walk means that for a lot of the computer science people know that, but for the others, what it means that when one page links to other pages, you sort of start a walk by, let's suppose, giving every web page $1, 1 rupee, and you follow the links, and every round you have to donate your links, donate your money, all the money that you have, equally among the pages that you link to. So essentially, if a lot of people link to you, you keep getting money, and if you are linking to a lot of people, you sort of give out your money and it just flows out. But you give out, if you have a lot of people that you're linking, each link possibly gets a small amount of money. So what happens in PageRank if you run this and then you keep giving the money until it does reach a steady state, which means after that the changes in the money is not that much. Okay, so it reaches equilibrium. So at that equilibrium point, what happens is that if you think about a citation network, in this case, in a web page-based scenario, the links are going from one page to another, and it's a general graph. in a citation network is a very directed graph. That is, the links are always going to older papers. So an older paper cannot, a paper in 2019 cannot reference a paper in 2020 for obvious reasons. I mean, we haven't invented the time travel yet. So one of the issues with the citation-based ranking is it biases older papers. So the first paper written in the field, even though it wasn't that great, maybe a revolution came at paper number 5, but all the, because of the PageRank that we are doing, all the importance would go to the very oldest papers. And we have to correct for that. And in order to correct for that, there's this teleportation factor in PageRank, which means that I did not describe exactly PageRank to you. So you give out all your money, and from time to time, with some probability, you don't decide not to give out all your money to the people you're linking, but you just give out all your money to a few number of people picked at random. So people you're not linking. So that teleportation factor needs to be made higher in a citation network in order for all the money not to sink to the oldest papers. So I think the next talk will go into bias and so on. So in citation networks, there's this bias towards older papers, and we need to fix that. So I've been told that I have a few minutes left, so I'll go over this fast. So essentially, the way we model it, our graphs are, we have authors who link to each other. Publications have authors. Authors have co-authors. Publications have venues. And then publications have keywords. So once we get a query, we are trying to figure out which publications are the best. And we do it in 2 stages. First, you do a first stage, because we cannot run a more involved algorithm over the entire data set. So the first set is to do the old style TF-IDF or whatever you're doing, similarity, to find, let's say, 500 papers. Now with these 500 papers, we involve the knowledge graph to use the authors and the venues and the keywords, and we use citation counts of the authors, citation counts of the papers to prioritize the authors who are more cited more, to prioritize the publications more, and to prioritize the venues more. So there is detailed math in the papers. In interest of time, I won't talk about it. And we ran some results comparing it with all sorts of different existing work, including PageRank and variation of PageRank and Google Scholar, and our accuracy measures using the 2-stage model. Essentially, most of the signal is in the TC, which is basically the citation count based method, based re-ranking that worked best. And using all of that information in the knowledge graph helped us improve our results. We did some ablation experiments to figure out the different effect of the different layers, and you can see just using publications we get some amount, but at the end when we are using publications, authors, venues, and keywords, then the search quality goes up. So this is a simple example of where we were using knowledge that was coming in and so on. So I'll stop there. And we'll leave it to our moderator to see if we have time for questions.
Time for a couple of questions. Well,
There is.
Just curiosity that in future could this mechanism be available as a browser extension? Let me explain that. Say I am opening a full text PDF paper in writing, then this particular mechanism is available as a browser extension, because browser is now omnipresent as a unique software for everyone. So on that basis it can give me a set of recommended papers like that. So one of this particular kind of tool is available now, that is called S-Site. So if I open that particular browser plugin, so it says me that which particular paper contradicted that paper, which mentioned that paper, and which supported that paper. So that kind of thing.
Right. And so I think the question answers itself, is that there is already something like that. And yeah, sure, this is for citing. But in general, I guess that work needs to be done. We have not done a browser extension, but work needs to be done. But we could do that for author similarity. So if you search for an author name, we could say these are other similar authors. If you search for a paper, we could say these are other similar papers, and so on. So yeah, it's a good idea to say that, the things that we have been doing, if we can create browser extension, then it'll go beyond CiteSeer and be usable by other people.
Thank you. I have got a couple of questions, but I will catch you up in the
Sure.
lunch break.
Okay.
So let us thank Professor Mitra
Thank
for
you.
taking us through this knowledge graph.